My name is Richard Cuerden and I work for TRL, the UK's Transport Research Laboratory. And I'm going to speak now about vehicle safety design and what's happened over the last 60 or 70 years to get us to where we are today, and what we need to do next to achieve zero fatalities and serious injuries, and indeed slight injuries, on all of our roads. Now I'm going to try and do that in 20 minutes, which of course isn't possible, but let's see how we go. People often get confused when they think about vehicle safety design, especially these days when we all consider automated vehicles as the new thing. Well, perhaps some may be surprised if I was to make that Google car, as was in around 2010, become a standard vanguard that was driving around the Transport Road Research Laboratory's test track in Crowthorne, Berkshire in around 1959. So perhaps not everything is as new as we think. In the 1960s and 1970s, TRL did an awful lot of work exploring how automated vehicles could take over from the driver, could really help improve access to transport, perhaps for people with visual impairments or unable to drive for various reasons. Obviously, when you see these videos, you see the obligatory hand waving through the window. The Citroën DS was chosen, and it demonstrated that it could follow an electrical cable within the road surface. And the tests were very good, very successful. And we often use these to show perhaps not everything that we're talking about today when we talk about automated vehicles is as new as we thought. But really what was happening back really from the 1950s was collision investigation. Way back in the 1930s and perhaps before, people recognised the harm that increasing road use was causing. As we got more and more cars, lorries, vehicles on our roads, we were seeing more and more people be injured. And the science of accidentology became a common thing. It was common for people in the UK, at TRL initially, and then at Birmingham University, Loughborough University, Oxford. There were groups around academics, scientists, engineers who were investigating collisions. There was also the development, similar sort of time really, perhaps a little bit earlier, of police and national recording of collisions that were happening on the road. So you had this macro data, we had total numbers, and then we had these in-depth studies where people were really trying to understand what was happening. And if you put both of those two data sets together, you could monitor and evaluate what was causing the collisions and what was causing the injuries. You could think about, in the early days, the development of seatbelts, or the development of road markings, or the development of driver licensing, and those sorts of things. You could implement countermeasures. You could then let those go into the fleet, and you could see how they worked. What's happened more recently is that you don't just introduce the countermeasure, of course. You've got to make sure that it's future-proof. You've got to look for the changing population characteristics, environmental factors, perhaps changes to behaviour, rules of the road, and those sorts of things. And you have to do proper impact assessments and cost-benefit studies. But the overall concept of investigating what's going wrong, learning from it, and then making sure we improve is fundamental to a lot of what I will talk about today. So all of that work, investigating collisions, testing vehicles in laboratories, led to what we now take for granted to some degree, which is minimum vehicle safety standards, first within the UK and in the early parts of the EU, and it was the European 15, and then as the EU grew into the EU 28. And this was done through, initially through European regulations, which often then became UN regulations. There are some examples of this happening the other way, but typically British standards were set. They were negotiated with our European partners. They became became EC regulations that then became UN regulations. And I've listed some here with some pictures. So you've also got, in this time period, Euro NCAP starting in 1997. So we're seeing the whole bringing together of consumer testing of vehicles in the late 1990s, having to meet standards really for the first time. What did all that do? Well, if we look at the casualty numbers, we can see that we saw really good reductions in the number of people who were killed and seriously injured on the UK's roads up to around 2010. And if we look at who was really benefiting, it was car users. So when we saw that big reduction in numbers from around actually from a long time before, but when we had targets up till 2010, from the mid 1990s, it was the car occupants who were really benefiting, and they were benefiting from those regulations that we talked about in terms of front impact, side impact protection, and those sorts of things, and Euro NCAP. And who is it who's benefiting when we say car occupants? Well, if we look at the data, it was young men. And there's a range of reasons for that, or a range of potential reasons for that. So we're seeing this largest reduction for young males. Could be linked to exposure. Certainly within this time period, we've started to see its continuing trend of younger people and novice drivers starting driving later, or indeed not taking up driving, choosing not to take tests. Work I have done and others have done has shown that the improvements from vehicle safety has demonstrated to about 11% of the reduction in fatalities. So the primary contributory factor that's leading to the reduction in casualties that we're seeing has been because of the regulatory improvements to vehicle, typically secondary safety design, supported by the consumer programs, supported by Euro NCAP. And there's been other great things as well, with education, enforcement, testing, telematics have become popular in this time, improved road design and so on. So it's never just one thing. Okay, so that was the past. Let's have a quick think about the present. Those of you who've heard me speak before will not be surprised that I'm going to talk about the general safety regulations and pedestrian safety regulations. These are the European regulatory tools that allow vehicles to be type approved in Europe. They set the minimum standards. They rely on delegated regulations and also UN regulations. And what that means is that you bring the best of what's available through a minimum safety set to all vehicles. And then on top of that, we expect manufacturers, and we hope manufacturers try even harder, and they try and get 5 stars in Euro NCAP. And Matthew's going to talk about that, and others will talk about that today. And then the final sort of top of the pillar is that vehicle manufacturers will have their own in-house standards for safety. I want to talk a little bit about the work we've done supporting the Commission, because that takes us from the past to the present. Since about 2014, TRL has been looking at the general and pedestrian safety regulations and assessing what could be done to those to improve them. How could we add more measures to reduce the casualties that we're seeing on our roads across Europe and in the UK? And what that involved was a selection of 50 to 60 measures that was whittled down to 24-ish measures, and then to a final policy document when there were 17 or so measures, and then different options of how those 17 or so measures could be implemented. And those measures were for all vehicle types: passenger cars, lorries, vans, coaches, buses, and so on. The outcome of all this, so the really important thing, is that the European Parliament, the European Council, and the Commission all agreed, and so this all became law. It was voted through the European Parliament in 2019, around 2 years ago, and it was published. It entered into force in early January 2020. The first of these regulations then will be applied just over a year from now. When you introduce any new regulation, it's really important to make sure that what you're doing is going to be robust and relevant. There's no point just introducing rules that are going to cost industry money and not have the safety benefits you want, or worse, be counterintuitive, have unintended consequences. So a lot of effort goes into really understanding what any given measure that you're introducing will do, what the benefits will be, and how it may interact with other measures. So the work that we did looking at the new measures and the cost benefits, so how we could what benefits we would see from these new measures and what the costs would be, had to baseline on where we are today. So what that means is that we assume no further policy intervention in the transport sector. So there would just be the new regulations would come along and compare it to where we were today, but we would account for the mandatory things that were already in place that had come about more recently. So, for example, automated emergency brake systems and lane departure warning systems for trucks and buses, ESC for all vehicle types. All of those things had come around already, so are going to have an effect over time. So we've accounted for that. We've allowed for the benefits that's going to bring to the fleet, as indeed for the continued voluntary uptake of systems, really pushed through Euro NCAP and the good work that manufacturers are doing. So we've assumed a baseline that isn't just static, it's based on this changing, evolving world that would happen if the regulation didn't happen, but consumers continued to behave in the way that they were. Here's a very long list, I'm sorry, and it's hard to read and take all this in, but this gives you a feel for the measures we looked at. There's a lot of them. The vehicle categories, M1 is car, N1 is a light van, and so on. You start to get the range of measures, and they cover things that are designed to prevent the crash happening in the first place, things that are designed to, if a crash is going to happen, perhaps mitigate the severity of that crash. So advanced emergency braking systems are a good example where if they work really well, they'll prevent the crash, but perhaps in some instances they won't prevent the crash, but by braking to assist the driver, we're going to help reduce the impact speed and so reduce the injuries of that crash. And then finally, we've got the more traditional crashworthiness protection systems in there as well. So things like frontal full width impact, which doesn't sound very exciting, but it's in there because we're really trying to establish more equality for all road users. Historically, what we've done, and we've done some great work, as I showed on the earlier slides, with reducing casualties, albeit we seem to have hit a plateau, but we've been basing that, and it's been around perhaps young males. So the benefits have been more towards young males than perhaps more elderly vehicle users, or indeed women, who we know aren't protected as well by the restraint systems in the way that the crash test dummy device and the crash test itself are put together, the metrics we use. So by going to a frontal full width, we introduce another data point and we encourage better performance of those restraint systems. So we're going to protect more people. So the measures cover all parts of vehicle safety design. Let's have a quick look at one of them, which has attracted a lot of attention: intelligent speed assistance. Intelligent speed assistance is something that's, as it says in the name, is there to assist the driver. That's what it's there to do. The driver has a fairly complicated task. We don't always know, well, I'm honest, I don't always know what the speed limit is on a given road. Sometimes I've got to have a think about it. What intelligent speed assistance does is it helps me because the car can read the road signs, or it can have map-based systems, and it can help inform me around the speed that I should be travelling safely at any given time. It does not control my speed or limit my speed. It advises me and it encourages me through sensible warnings to adhere to the speed limits at that given time on that road. So of all those measures that I showed before and of all the work we've done in this rather complicated cost-benefit study, it's worth noting that the first thing, and perhaps the only thing that I've seen in the media when all of this was going through Parliament, was the kind of the BBC headline here: EU plans vehicle speed limiters from 2022. The EU does not plan vehicle speed limiters from 2022. The EU has adopted and is going forward with a whole range of vehicle safety measures that work together to prevent people being killed and seriously injured. And one of those measures is intelligent speed assistance. Again, it does not limit the speed. But this is when it's so important to explain and to ensure that the public are coming along the journey in terms of how these systems are going to work. And that's going to get more complicated as we go to more advanced assistance and indeed automated systems. So I mentioned that we've built a rather complicated model. We've actually produced a in my view, a safe system model, or using a safe system approach. So we've taken all of the EU road casualties and we've said, okay, of these 17 measures, if you applied them to the collisions that were happening over recent years, which collisions would simply go away? If we had a range of people who were following the speed limit, what collisions wouldn't happen? And we can remove them. And we can do that for tire pressure monitoring and driver distraction and so on. That then leaves a remaining target population. So then we can look at that group and we can look at the collision data, and we can also remember that we've got ESC that's going to become more commonly fitted throughout the fleet, because it's not 100% at the moment, electronic stability control. And we can then say, okay, of the remaining population, which of these crashes are going to be prevented and effectively go away? So again, we reduce the target population. However, some collisions are going to be remaining. Some of those will be at a lower speed, thanks to the active safety measures, and some will be unaffected. And for those measures, and the example I'm showing here is for passenger cars, we then look at, okay, that's the group who would be affected by the new frontal impact test, or the new pole side impact test. What that means is that if you take intelligent speed assistance and you take the automated emergency braking and the lane keep assist, you can say, well, or the pedestrian collision detection measures, you can say, well, they're using the same camera, the same technology. Let's not count multiple cameras for each of those measures. Let's just count that once. And indeed, what we do is, by following this method, we don't double count the casualties either. It's really important that we can show and demonstrate that we're not overestimating casualties or indeed costs. Okay, far too much information on this slide, I apologise. And you can read within the EC TRL report all the work that went on, but it followed the European Commission's regulatory scrutiny guidelines. So that means you've got to do all sorts of simulation and calculations within the model. You've got to look at inflation for monetary values, you've got to look at sensitivity and so on. And we've done all of that, and I'll come to the results in a moment. But the note I wanted to make is that what was really interesting when we were doing all this was that cars have become cheaper in real terms every year over the last reported decade, despite the fact that we've had more demanding environmental and safety standards, and despite the fact that cars and vans and lorries come with more gadgets on board. So in real terms, vehicles are not getting more expensive, and they definitely are getting better. And you can see in the tables the monetary values for casualties and the cost values for original equipment manufacturers per vehicle. I really won't talk about this slide. It's just to show we did some serious work. Go read the report or come and ask me some questions afterwards. Okay, what did we find? Casualty savings and cost effectiveness of the revisions of the general safety and pedestrian safety regulations. Around 700,000 casualties could be prevented, 25,000 fatalities. The benefits to society exceeded the costs, and really importantly, because we really engaged with stakeholders throughout the whole process, from all different parts of the stakeholder landscape, you can see that the general safety proposal is designed in a way to help the industry to remain competitive by increasing the production, the scale of the cameras, of the intelligent systems that are going into vehicles. It's going to reduce the price. So we think this is really good for industry as well as really good for society. Okay, here's the more challenging part of my presentation. The UK position on the general safety regulation and pedestrian safety regulation, now we're not part of the European Union, is that we have not made a decision yet. The UK can choose to adopt it in full, choose to adopt partially some of those measures, or it could choose not to adopt any of it at all. However, the cost effectiveness benefits are only achieved if you take the full package. The EU type approval is comprised of EC directives and UN regulations. So when you hear people talk of, well, the UK will just follow the UN route, that's fine, but we'll be accepting a significantly lower level of minimum safety requirements. So without action, the UK will be falling behind our friends over the channel. Okay, the future. These are some slides that I've been informed by all sorts of people, probably this first one by the Law Commission and their recent work. So we can think about automated vehicles in perhaps two ways. We can think about them as a continuation of the sorts of vehicles that we have on the road today, with steering wheels, and for some journeys the driver doesn't drive, the vehicle takes over. A good example here is all lane keeping systems, which a lot of us have been hearing around. So I'm driving along on a motorway, I come to some traffic congestion, I sit back and I let the vehicle do the driving at that point. Or perhaps there's the other extreme where, in the first instance, in limited operational design domains, so perhaps in urban areas, we get into new novel types of vehicles and they do all the driving, and there's no steering wheel at all, there's no driver. This slide, this video, is really showing work that we've been doing. The first work we did was the Gateway trials, which I believe were the first in Europe where we had mass participation of automated vehicle engagement, where we got people in these pods to experience how they worked, to understand how they would or wouldn't use them in the future. And we learned all sorts of things about how you may or may not want to run services of this kind. But again, it's running something without a driver. And then if you think about the future and we think about the driver not being in the loop, this was a news item I saw about 5 years ago on the BBC website, where a US cinema chain, which very quickly changed its mind, by the way, but at the time said they were going to allow people to text in movie theatres. And I imagined a world whereby the UK Department for Transport is set to allow drivers to text at the wheel. Because if we imagine a vehicle that can drive for us, surely we can do that. Surely we can do whatever we want when that vehicle is safely driving for us. Can't we? Well, maybe. And how would we get there? And certainly when I talk to my daughter, who's pictured here, sometimes I wonder if the question is driving distracting when we want to be online, rather than is being online distracting us from driving? And that's no disrespect to my daughter at all. Simply what I mean by that is that she is motivated, as many people are, by being in contact with her friends, by being part of an online society, in a way that certainly wasn't the case for me when I was her age. Okay, I didn't have a good video for an all-lane keeping system, but this gives the idea. This shows traffic jam assist. So the driver in this case has been driving along on a highway, has come to a traffic jam, decides to let the vehicle drive in these limited conditions to certain speeds, keeps the vehicle in lane, and as you can see in the video, is then perhaps doing his emails or having phone conversations or whatever it may be. The vehicle then goes past this particular, whatever caused the traffic jam, and away we go. He then would take over the driving task again. So how would we approve vehicles like that? Well, conventionally, we have whole vehicle type approval through the European Commission, which comprises of tests, so physical tests and audit, conformity of production, so you make sure that the vehicle you've tested, all the other vehicles are going to perform in the same way. And then we have, more recently, market surveillance, so you check that the vehicles are being actually sold that still meet the requirements, so be that emissions or safety or whatever it may be. And you have periodic technical inspection, or MOTs, and that can link to a recall system. Let's imagine a world now, though, where we think about whole vehicle type approval for automated vehicles. Life all of a sudden has got more complicated, because we're going to have to now think about virtual tests. We can't possibly test all of the different physical ways that a vehicle encounters it would have. We've got to think virtual testing. And we've got to think of driving tests for the vehicle. And instead of periodical or annual technical inspections, we've got to have continuous technical inspections of that vehicle, continual monitoring of how it's working, how it's performing. So when we talk about automated vehicles and whole vehicle type approval, I guess the question is what is missing and what the challenge is. Well, the first obvious thing to say is this has never been done before, and it's going to be really hard. And it would be ambitious of us to imagine that if we were to do this, we would get it perfectly right first time. So we're going to have to think about how we put regulation and standards in place and learn really quickly. And one of the best ways to learn, as we started this presentation with, is investigating. Certainly investigating things before things go wrong, but unfortunately if things do go wrong, let's investigate those collisions and learn from them as well. Most of the testing and evidence is going to come from simulation. So we need confidence that the simulation is adequate. How are we going to do that? We're going to have to develop digital twins, we have to develop new simulation tests based on scenario databases. There's a whole science of testing which needs to be developed. This is just a slide to show that the UK still has the capability to investigate road collisions, and this is a picture of the TRL team. And indeed, today we can go out and we can investigate collisions, and we can download event data recorder information that, if the UK adopts the general safety regulations, will be mandatory in the UK. And the trace here is showing a driver who very late took his foot off the accelerator and braked. You can really start to understand what was going on in those sorts of collisions, and if the vehicle had had an automated emergency braking system, you'd understand how that had performed as well. I wanted also to talk about the fact that the vehicle fleet is changing. The light blue line here shows the share of SUVs in the total fleet, if you will, and since the 1st of January 2010, across Europe it was around 10% of the fleet. As of the 1st of January 2019, SUVs, sports utility vehicles, were 36% of the fleet. Now these are really different vehicles and represent a different challenge, especially when they're in collisions with vulnerable road users, with pedestrians and cyclists. Here's the old-fashioned way that we used to imagine how you'd have a wraparound, so if a vehicle hit a pedestrian, a child, through to an adult, how their heads would strike different parts of the vehicle. And so when we talked about, on one of the first slides, when we talked about the UN regulation, and we said the pedestrian protection had come in, we have this lower leg form, we have an upper leg form, and we have a head form, and these are fired into the vehicle. Interestingly, the upper leg form is just for monitoring purposes, but nonetheless it exists, and it's certainly carried forward in Euro NCAP. When you apply an MPV in this case, or a multi-purpose vehicle, which is the red line, you start to see how a pedestrian would be struck very differently. The geometry is going to mean that you've got a very different way of connecting with the pedestrian. They're going to hit different parts of the vehicle, often parts of the vehicle which, through the original regulation, prior to the amendments that are going through the pedestrian safety regulation, which again the UK needs to sign up to, because if it doesn't, our vehicles may not be being tested to be impacted in the areas where real heads are striking the vehicles. The changes to the pedestrian safety regulation mean that the strikes now are allowed to go into the windshield area. They're not just restricted to the bonnet like before. And the same is true when you look at SUV profiles. So what's really important here is that we adopt the better regulation so we can start to see safer vehicle design. But then the thing I want to say very quickly here is that when we've always been restricted when we've designed vehicles to protect pedestrians, because vehicles have had engines, they've had internal combustion engines that take up a lot of space. As we move now to an electric vehicle fleet, we're going to be afforded much more space at the front of that vehicle. And certainly when we think about vehicles that are perhaps just designed solely for urban areas where we're going to have a lot of pedestrians, a lot of cyclists, we can design those vehicles to be much more forgiving in the event of an impact with a pedestrian. So we can really improve the protection we offer pedestrians and cyclists, because we don't have the constraints we've had in the past. So we can cost effectively make good changes. Okay, I've overrun, but I will finish with my concluding remarks. The purpose of the conference that we're at today was to look at the policy links between, I guess, reducing emissions, the carbon safety link, if you will, And the opportunity, therefore, in my opinion, the UK has to lead here. Because if we plan for zero carbon journeys with zero fatalities, we can start to realise what we have to do to achieve that. I've listed all of the things on cabs, and I've talked about these before. So connected automated vehicles are going to change the way we travel. Quite when and how, we're not quite sure, but it's definitely going to happen. And it's going to require lots of changes to lots of rules. And the Law Commission and others are working on that now. And finally, I've already said this, but the general safety and pedestrian regulations must be urgently adopted in full by the UK. Next steps, well, as all these new technologies come along and we see the population demographics changing with different freight and passenger characteristics on our roads, different sorts of journeys, we're going to have to plan to make sure that we have equality in terms of safety. At the moment, it's rather unfair. If you're a vulnerable road user, you're much more likely to be injured in the event of a collision. We also know that could mean that you're just an elderly car occupant, or perhaps you're a female within a vehicle, or perhaps it means you're more vulnerable through your age. Whatever the reason is, we need to be designing systems that protect all road users much better than we have in the past. And that joined up approach through design and regulation of vehicles needs to be put in place so road transport produces zero emissions and zero casualties. Apologies that I overrun a little bit. Thank you very much for listening, and I look forward to taking any questions later on. Thank you very much.